as we get ready to see the launch of the next crew to space. The crew members who are already on board the International Space Station are continuing to work on the variety of science there. There is still a series of tests going on board the International Space Station today that started before the construction of the space station began, back when the Space Shuttle was our only orbiting science laboratory. Lori Meggs joins us from the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama this morning to talk about growing protein crystals in microgravity.
That's right, that very subject, protein crystal growth, is proving useful in the design of new pharmaceuticals, specifically a drug to prevent Duchenne's muscular dystrophy. That's where there is a defective gene for proteins in the muscles. I had the opportunity to speak with the lead investigator for this project at the Osaka Biotechnology Institute in Japan.
I studied protein crystallography to know the tertiary structure of the various proteins. And also now we try to make a good drug used for the prevention of the muscle loss of the Duchenne's muscular dystrophy. To design the drug, so we use the crystallization of the protein and drug complex under the microgravity condition in International Space Station.
Why did you want to study protein crystal growth at first?
Yeah, the original idea is just several researchers proposed that the microgravity is very effective to prepare the well-ordered structures of the high-quality crystal. But we are not sure. Then the one day is the JAXA, previously named NASDA of the Japanese Space Agency, give us a chance to participate in the Space Shuttle project to check the crystal quality growing the microgravity condition of Space Shuttle. That is our starting point. Then by combination of the microgravity to prepare the high quality crystal and also using the super powered X-ray to define the fine structures. So those combination is very, very useful to understand how that chemical structure bound to the target protein. That completely the fine structure of the target cavity, we can design much more better structured drug. So diagnosis is very easy because that disease is a genetic due to the genetic mutation of this gene. Therefore, the diagnosis is very easy by genetic diagnosis, but no therapy at all, nothing to do. And year by year, the muscle was weakened. And also end of the junior school, they have to use wheeling chairs. Once they start to use the wheeling chairs, muscle was much more weakened rapidly. And until the 20 years old, they have to use artificial aspiration machine. Then, okay, they can maintain the life 20 years more. But finally, respiration is very difficult. Most boys will die by the respiration failure or the heart failures. But once we found the good drug candidates, and I administered those drug candidates to the model animal of DMD. So without touching any gene, we can slow down the progression of the disease.
How did you make the connection between Duchenne's muscular dystrophy and your protein crystal growth?
It was really the suddenly accidental finding. Almost 10 years ago, one Dr. co-student of the Department of Pediatrics of the neighboring university visited my office, and he found that is the normal histological studies. He found our enzyme is also upregulated in the damaged smooth muscle of the patient with Duchenne's muscular dystrophy. So until that time, I did not know anything about the DMD. But then he explained how serious that disease. By using the chemical drug, that we can, control the drug phenotype. The genotype, we cannot touch it. Even though we can control the phenotype, just like a case of HIV. So now it's to 10 years or 20 years later, so many people died by HIV. But now in the United States, most cases we can control. I want to realize their drug, distributed new drugs for every patient everywhere, and with a very cheap price. This is my dream.
And that just shows you that research can take years, but the results are well worth the wait. Very interesting research there. And taking a live look in the Payload Operations Integration Center, Mike Faust is the Payload Operations Director today, and they are getting ready with all of the excitement with the new launch of a new crew, and that means a lot of exciting new work and science investigations here from the Payload Operations Integration Center.